everyone, I'm Shankar, and I'm here today to present our project demo that is Academic Credential Issuance and Verification System, developed by me and my co-author Deepak. So in today's world, verifying academic certificates is still slow, it is centralized, and vulnerable to fraud or data loss. Our system solves this using blockchain, IPFS, and cryptographic thresholding. So we ensure that the certificates are secure, verifiable, and also recoverable even after the issuing institution disappears. Let me quickly wire up our front end and back end. So here is the sign up page of our system. Both the student and the university will have to, create their accounts. Let us create a demo university, BMSIT. So we have created our university account. Let us go and create the student account, because if we try to issue a certificate for the student without a student account, if the student is not present, it will show an error because the student does not exist. As we can see here, we were not able to issue certificate because the student does not exist. Let us go and create the student account. Here we need to select the university and one. So I have created the student account and I have logged in. So let me log back to the university account. University email is admin@bmsit.com. You can also log in using Google itself if you have a Google account attached during the login process. Now we can issue a certificate for the student. So basically the process, what is happening is in the client side, the encryption, we are doing it using AES-256 GCM algorithm. That is the advanced encryption standard. And these encrypted credentials, it is being stored on IPFS, that is interplanetary file system. And the metadata that ensures the integrity and authenticity, that will be stored in Ethereum blockchain. These encryption keys that we obtain after that, we will split it using Shamir's secret sharing algorithm. And using this split keys is how we will be able to recover the certificates, even if the issuing institution disappears later on. We can check the console logs here that the certificate we just issued, it has been uploaded to IPFS, and the credential is also issued on blockchain. And now if we go back to the student account, log into the student account, we can check that the certificate has been issued to the student. Here you go, we have the certificate that has been issued right now. We also have the file hash, the JSON hash, and the IPFS CID. This is content identifier. Using this IPFS CID, we can locate the file in our IPFS. Now, if we look at the blockchain transaction, you can see the blockchain transaction of the certificate we just issued. We are using Sepolia testnet as of now. Here is the transaction hash, and the same exact transaction hash we found it in a console log as well. Here our issue credential contract has also been called. We can all see this. So now if we log back to our university account, we can have a look at all the certificates that the university has issued along with all the credentials. Here in the manage certificates section, we can see the certificates that the university has issued for all the students. Right now the student is only Shankar. And we also can access the file hash of the certificate, IPFS CID content identifier where the certificate is stored, and the blockchain transaction ID, through which we can go to the Sepolia testnet and confirm the transaction of the certificate. I have just demonstrated the certificate issuing process. Let us now look into the certificate verification process. So here, let us say I'm the person who wants to verify these certificates. I'll have that certificate that I just issued for the student. Here we can see the process. And we can see that it is a valid certificate that has been issued. So the process that is happening behind is the client, the person who is trying to verify this, they generate a random AES key, and this document is encrypted locally there. And the ciphertext that we obtain after this encryption is uploaded to IPFS. So the SHA-256 algorithms hash is computed, and the metadata is anchored through the blockchain. And this ensures that the server, it never sees the plain text certificate. We can also have a look at the console logs here. for the verification request, and the file hash that the particular certificate generated, and the results in the blockchain and the database. One more feature is that it is not just with the file upload that we can verify the certificate. We can also use the metadata in order to verify the certificate and ensure it is a valid certificate. Now let us have a look at what will happen if we try to verify a non-issued certificate. This certificate we have not issued to any student, and we can see that it shows it's an invalid certificate. Let us have a look at our console logs. So we can see that there was an error verifying credential on the chain, and the credential is not found. And why the credential is not found, and the reason, everything we can see in the console logs. And at the end, we get the output that the credential is not found in the blockchain. And it is not just only these two cases. We have tested multiple cases, like what if the student does not have an account at the university issue certificate? What if the university disappears and the student is present? And all these cases, we can have test cases. You can have a look at them in our blog. In our blog, we have uploaded all the test cases and the resulting outputs of each of these test cases. So if I have to summarize the results of a project, our testings, they showed 100% verification accuracy and also successful recovery without the issuer, zero text, plain text leakage, and strong resistance to tampering. So to conclude, we can say that our system, it provides a secure, tamper-proof, and recoverable academic credential infrastructure that removes institutional dependency. It decentralizes it while also preserving privacy and trust. The future scope we have in mind is we are planning to integrate mobile wallet support and also selective zero knowledge disclosure. Thank you for watching, guys.